Welcome back. Have you ever wondered why oil and water just don't get along? The answer lies in chemistry and the unique properties of these two substances. Today we're diving into 18 fascinating facts that explain why oil and water won't mix, no matter how hard you shake them. Did you know that water molecules are polar, while oil molecules are nonpolar? This fundamental difference means they don't interact in a way that allows them to mix. Did you know that water molecules have a strong hydrogen bond network? These bonds make water molecules stick tightly to each other, leaving no room for oil molecules to integrate. Did you know that oil molecules are hydrophobic? The term means water-fearing, and oil actively avoids contact with water due to its nonpolar nature. Did you know that water molecules form a cage around oil molecules? This phenomenon, called the hydrophobic effect, increases water's surface tension, further preventing mixing. Did you know that water's high surface tension causes it to form droplets? This makes water and oil separate into distinct layers, with water sinking because it's denser. Did you know that the density difference between water and oil causes oil to float? Water is denser because of its tightly packed hydrogen-bonded structure, whereas oil molecules are loosely packed. Did you know that the term "like dissolves like" explains why oil and water can't mix? Polar substances dissolve in polar solvents, and nonpolar substances dissolve in nonpolar solvents, but the two don't mix. Did you know that adding an emulsifier can make oil and water mix temporarily? Emulsifiers like soap have both hydrophilic, water-loving, and hydrophobic, oil-loving ends, allowing them to stabilize the mixture. Did you know that oil and water can form emulsions? These mixtures, like mayonnaise or salad dressing, are stable because emulsifiers prevent the separation of the two layers. Did you know that the molecular size of oil molecules prevents them from bonding with water? Oil molecules are too large and nonpolar to form hydrogen bonds with water molecules. Did you know that water molecules arrange themselves more rigidly when oil is present? This reorganization increases water's order and reduces its ability to mix with oil. Did you know that temperature affects oil and water separation? Heating can reduce surface tension slightly, but not enough to make them mix naturally. Did you know that oil and water interactions are critical in biology? Cell membranes rely on the same principles, with lipid bilayers keeping the watery inside of a cell separate from the outside environment. Did you know that water's polarity makes it an excellent solvent for salts but not oils? Polar compounds like salts dissolve easily in water, while oils, being nonpolar, don't interact. Did you know that shaking oil and water creates temporary dispersion, but not mixing? Shaking breaks oil into small droplets that float in water, but they quickly coalesce back into a separate layer. Did you know that oil molecules prefer to stick together due to van der Waals forces? These weak interactions between nonpolar molecules encourage oil to form a separate layer instead of mixing with water. Did you know that detergents break up oil by reducing surface tension? The hydrophobic ends of detergent molecules attach to oil, while their hydrophilic ends interact with water, allowing oil to disperse. Did you know that oil spills rely on surfactants to clean up? Surfactants break oil into smaller droplets that can be removed, overcoming the natural separation between oil and water. Oil and water are like the ultimate opposites, refusing to mix due to their molecular structures and interactions. From hydrogen bonding to emulsifiers, the science behind this phenomenon is both fascinating and practical. If you enjoyed learning about these unique properties, don't forget to like the video and subscribe for more deep dives into the wonders of chemistry. Let us know in the comments which fact surprised you the most. Thanks for watching, and we'll see you next time.